Alright guys, so this is the second video here and we're going to get to it. This problem here is asking me to convert from polar to rectangular. So these two equations are given to you. This is what I'm going to use to convert my polar coordinate. Again, I can tell it's polar because of the pi. Also, if it had a degree symbol, that would also mean it's a polar coordinate. So where this value is the r and this one's the theta. Okay. So pretty much I just plug in here. So my r value is 2, so I'm going to multiply 2 cosine of my theta, which I know is 3 pi over 2. And here, so do the same thing, so 2 times the sine of 3 pi over 2. So I'm going to need the unit circle here, so I'm going to look at the unit circle. I have one up here. I'm looking at the cosine of 3 pi over 2. So if I'm looking here, 3 pi over 2 is right here. And remember that the x value here is the cosine and this is the sine. So for my cosine of 3 pi over 2, my value is 0. So I'm going to come back here. This now becomes 2 times 0, not cosine 0, but 0, which is equal to 0. And sine of 3 pi over 2, I'll go back to the unit circle. The sine value, which is the y, or the second value, is negative 1. So this becomes 2 times negative 1, which equals negative 2. So my x and y is 0 and negative 2. Okay. So this one's converting my equation from polar to rectangular. So remember, this is my relationship right here. And we're going to go ahead and use the unit circle again. So here I'm going to do the tangent of pi over 4 is equal to y over x. So again, I'm going to use a unit circle, so I'm going to look right here, and pi over 4 is right here. Right here. So remember, this is the x and this is the y, and tangent is y divided by x. So if I divide this number right here, square root of 2 over 2, by square root of 2 over 2, it's going to equal 1, because the tangent value is not there. So 1 is equal to y over x, and I'm going to multiply by x, so y is equal to x. That's my equation right there. Okay, so I'm going to give you guys a few points here. We're going to go ahead and plot this one. I'm skipping the other one just for a second right now. So 2 and 120, we'll do, let's see, negative 2 and 300, and two negative 60, and one more point here. Let's say three and 240. Okay, so if I were to plot these points, remember I told you to start. This is an r and this is a theta. These are degrees, by the way. Sorry. So I'd go to 120, and then from here I'm going to go 1, 2 out. That's point A. Okay. If I were to do negative 2 and 300, well, 300 is right here, but because it's negative, then I need to go the opposite side. So 1 and 2. So I already have a point here, guys. So remember, you can have more than one point in the same spot. So B is at the same point. Okay. I'm going to go to negative 60. So remember, this is not on the unit circle, so I'm going to keep adding 360 until it is. If I do that, 300 degrees, yeah, that's on the unit circle. So, excuse me, on the circle. So 300, and then from here I want to go 1, 2 out. So this is my C, and then last one, 240 and 3. So 240 and 1, 2, 3. So that's a point D. Okay, so just a quick review on how to plot these points. This is like going to be maybe, I guess, one of the harder ones to do, and so, excuse me. This one here is asking to determine how far the tennis ball traveled, and so this is, excuse me, what we call projectile parametric, where I have an x equation, which is v initial t cosine theta, and I have an equation for y, which is a little bit longer. V initial t sine theta minus 1/2 gt squared plus h initial. And so I need these parameters here. So I'm going to look for them right now. My initial velocity, my angle, my initial height, and also my constant for gravity. Okay, and so that's going to change, guys. I know you're used to seeing 9.8, and that's what it is in metric units, but we're going to see here, tennis ball travels at an angle of 68 degrees with initial speed of 64 feet per second. So you can start filling in some of this stuff. Feet per second. Theta is 68 degrees. So my initial height of 7 feet, so 7 feet. And this is where you guys are gonna, I've seen some confusion. Gravity, guys, remember I'm dealing with feet here, feet. So when it's feet, it's 32.2 feet per second squared. That's what I needed to work with. So as I plug these equations in, I'm doing my initial velocity, which is 64 t cosine 68 degrees. And again here, 64 times t sine of 68 degrees minus 1/2 32.2 t squared plus 7. Okay, so this question's asking me how far the tennis ball will travel. So if I'm asking how far, guys, I need to use this equation. This is the one I want. How far? Now the problem with this is right now I can't just plug this equation to the calculator because I don't know a time. So I'm going to plug this equation. I need the y equation to find my time. So I'm going to solve for t. And the way we're going to do that is by graphing. So I went ahead and graphed it already. And this is what it looks like. So I just want you to see the way I plugged it in also. Don't forget, you need to put the degree symbol like I did here, just so the calculator reads it, and degrees. You need to put a times between every single number because your calculator's a little picky that way. And you'll find that you'll end up with this curve. Okay, and so what I have now is the y direction, how far up it goes, and this is measuring time. So when the tennis ball reaches the ground, like it does right here, that's the time I want to know. When is it crossing the x-axis? Because that's when it hits the ground. So I'm going to use the trace function here, and I'm going to look for when it says 0. This might take a little while, but it's okay. It's getting lower, lower. You can see the y decreasing, and right there it says 0. So this x value is time, so it takes me, my t is equal to 3.8 seconds. That's how long it takes me to reach that. So what I'm going to do is, now that I know a time, I'm going to plug it into my x equation. So 64 times 3.8 cosine of 68 degrees. And when I do that, I'm going to go ahead and just plug that in the calculator. You will have a calculator for something like this. I get that it is 91.1 feet, which is answer D. Oops, sorry. So this is how you work through these problems, guys. Again, please study. These are here for a reference for you, so keep going at it and study hard.